just two quick more things we want to cover for our course in regards to regression, and then that is it. Um, I will also send an email out soon about the some final exam information. But let me just show real quick how to do these last couple of things in regards to regression and correlation. Um, so quickly, in regards to correlation, yeah, this correlation coefficient R. I want to show you how to compute that real quick. So quickly, let me just say that correlation is a measure of how linear your data is. I will let you guys read the notes on your own about correlation. Um, but just in short, it's a measure of just how linear your data is. So if correlation is close to 1, if the number is close to 1, we say it's very linear. Or if it's close to -1, it's also very linear, just going with a negative slope. But if it's close to 1 or -1, if the correlation is close to 1 or -1, we say the data is very linear. If the correlation is close to 0, then that means it's not linear at all. Okay, but let me show you how to compute this on Excel. Um, so for a problem like this is question number 6 on the 2.4 homework section. Um, so first of all, let's see. Here we have yeah, some times and some connections of something. But anyway, we have our x values and our y values. I mean, it's t and c, but I mean, still, it's just like x and y, right? Um, so to compute, yeah, so this one's asking us for the linear regression line. I'm going to skip that right now since I've already done that, and I'll review that in just a moment anyway. But I really want to focus on the new thing, which is computing the correlation. So for that, so we first have to enter in our data into Excel, just like we've done similarly in the past. So I have my quote unquote x values, 0 through 4. So 0, 1, 2, 3, 4. Now I'm going to enter in my y values. I mean, they call them c here, but anyway, 5, 15, 30. 5, 15, 30. 70, 155. 70, 155. So again, just entering the x and y values like we did last time in regards to regression. Okay, so correlation concerns x values and y values. On Excel, it's the equals, don't forget that equal sign, CORREL. So this equals CORREL. This is what you need to compute correlation in parentheses. And you'll notice it says array 1, comma, array 2, because it's not just a single x value and a y value, but rather a bunch of x values compared to a bunch of y values. So array 1 concerns all your x values. So you could highlight or type A1 colon A5. Okay. Make sure you have the comma. You have to be sure to put the comma there to tell Excel that now you're going to focus on your y values. Okay. So you got to type the comma and then click and highlight your y values. Or type like B1 colon B5 like this. Either way. Close the parenthesis. So Excel is going to compute the correlation of the x values versus the y values. Hit enter, and we get 0.91. So somewhat linear. I mean, it's 0.91 is sort of close to 1. So that's somewhat linear. Yeah, if the correlation was like 0.99, we would say that's very linear. But anyway, it has some linear pattern. It is a 0.91 is close to 1.0, right? I mean, so that there's some linearity here. Anyway, I will let you read up, everything on the notes about correlation, but that's how you compute it. That's how you compute it. So, okay, so I'm going to move on from here and go on to the last thing I want to talk about with you guys is nonlinear regression. Briefly, let me just say that sometimes data sets are not linear at all. Sometimes they could be quite curvy.
Um, so for example, by the way, this is the 2.8 homework set here for nonlinear regression. Yeah, see if you had a graph like this, it's not really a line at all. It's a curve. So for something like this, um, it would be silly to ask what's the line that best fits the data. Probably would be better to ask, like they ask here, what's the best quadratic function that best fits the data, that best describes this data. So we would say this is quadratic regression. Or maybe you have data that's really curvy and it's good to use something like an exponential curve or a logarithmic curve or whatever. But the point is, it's not always best to just use linear regression. A line isn't very good all the time. Um, so let me show you real quick how to do exponential regression or quadratic regression or whatever. Honest to goodness, it's the same steps as the linear regression. You just have one extra step where you click a different button at the end. Let me show you what I mean. So, okay, exponential regression here. If it was linear regression, what would we do? We would enter in our data first. Same thing we got to do here. So make this a little bit bigger. Okay, 1, 2, 3, 5, 4, 9. 1, 2, 3, 5, 4, 9. Again, like x value, y value. 1, 2, 3, 5, 4, 9. Okay, and then 5, 18. 5, 18. Okay. And again, this will also serve as a little bit of a review in regards to linear regression. The steps are almost identical here. Okay, so now we have to highlight our data and go up to the Insert tab, just like we did last time in class. Once again, we're going to need a scatter plot. Click my dots here for the scatter. Again, just the most basic scatter plot will suffice. Okay. And just a quick comment here. Notice this data here is curvy. It doesn't really look like a line at all. It really it looks like an exponential function, the way it kind of builds up like this. Yeah, so you could think about linear regression and whatnot, but probably exponential regression or something else would be a lot better. Okay, so once again, we're going to get, let's see, so on my computer here, I don't seem to have that little plus sign that I had in class on the PC. Yeah, if you have that little plus sign, you could click that and get the trend line and more options. Otherwise, you could go on top of one of the dots, put your cursor right on top of one of the dots, and right click. Okay, and get the add trend line option here. Again, it might look different for different versions of Excel and different computers, but you could either click that little green plus that was up here and go to the trend line and get the more options, or you could right click on top of one of the dots and get to this trend line like this. Okay, but anyway, we click this, and what pops up? So this is the regression line that we had last time in class. This was the regression line we had last time in class. And if you wanted the equation for that regression line, recall that what you have to do is you have to come over here to this chart. Let me see. How do I? Oh, I don't have to scroll down here, but yeah, this, and you have to come down to the bottom of this chart and see where it says display equation on chart. So if you click that, yeah, so this line here, I'm sorry, this equation here, this is the equation for the linear regression. This is the line, like mx plus b. This is the equation of the line. Okay, so that's what we did last time. So what if you want to do, exponential regression or quadratic regression or logarithmic regression or some other curve? It's the same steps. I mean, still you go to add trend line. Now here's the only difference. Take a look at your options over here.
On the right, you have exponential, linear, logarithmic, some other things. So for example, if you want the logarithmic curve that best fit the data, you click that button there. Oh, hold on, I still got the. Let me redo this because I have the old one is still there and I want it to go away. So let me get a new scatter plot. Keep this clean. Okay, so if I want the logarithmic curve, I just click the logarithmic button. So it looks bad because this data is not really logarithmic at all, but that would be the logarithmic regression curve. Um, if you want the exponential regression curve, you just click exponential, and there it is. And there it is. So also too, let me just point out real quick. One of your problems asks for the quadratic regression curve. The quadratic regression curve. Okay, take a note here, please, because you will notice there is no quadratic option on Excel. Okay? However, a quadratic function technically is a polynomial of order 2, because it's like x squared for a quadratic. So please note that. Please take note of that. Whenever it asks for quadratic regression, you have to select polynomial of order 2. Okay? That will give you your quadratic curve. Okay? Anyway, so for the problem I was working on, it was asking for exponential regression. So I'll go back up and click the exponential curve option up here. Again, display equation on chart, just the same. And it's kind of small, but I got some crazy thing here. 1.0892, 1.0892. And then it's that e raised to the 0.5422x. 0.5422x. Like this. Okay. Okay. And that should be it. So honest to goodness, it's the same steps as what we did in the past. The only difference was you just click on that little, it's hard to get the pop back up again. Yeah, the only difference is you just click on your option over here. Okay, but everything else works just the same. You can also use so for example, you can use the exponential regression curve to make predictions. One of your homework problems down here, it says it asks for an exponential regression model in terms of P of t, so a t instead of x. I mean, not a big deal here. Asks for a sketch. But then extrapolate your model to estimate. Right. So let me come back up here. So this table shows the price of a apartment in New York City. Okay, from certain times. Right. So you gotta be a little bit careful here. The starting point is 1994. So it goes up to 10, which would actually be 2004. So be a little bit careful with this problem. But the idea is we can get an exponential regression curve from this data, and then we could use it to make predictions. So for example, the problem down here, it says extrapolate your model to estimate the cost of an apartment in 2008. So extrapolate your model, that just means use your function to make a prediction. Okay? So we would basically plug 2008 into our function, like for our t value. Be a little careful of this problem though, because see, 2004 was here. Yeah, 2004 was 10. So if you wanted to have 2008, that would be 14. Do you see that? Because, 2008, you can't just use 8 for t. It doesn't quite work like that. Yeah, since 2004 was 10, you have to add 4 years to that to get 2008. So it would be 10 plus 4, so it would be 14. What we would have to enter in for your t value. Okay? Okay? So be a little bit careful of that. Um, and honest to goodness, I think that's all you guys need. Okay, so you got that correlation, nonlinear regression, just hit a different button. And otherwise, all this stuff works the same. Okay, and again, I will send out an email about the final exam, some of my thoughts, and I'll just be in contact with you guys. Okay, take care.